Okay, welcome to the third and final video that I'm going to make on unit circle trigonometry. Um, so let me just first explain some of the diagrams. This is the same diagram we saw before with the special angles and values of trigonometric values of the special angles for the entire unit circle, and I just want to demonstrate more completely something I started with last time. We know this is the equation for a unit circle. Hopefully you realize that from algebra. This is centered at 0, 0, and has a radius of 1. And we also saw the Pythagorean identity. Of course, we know that x is equal to cosine of the theta. I really should have put theta here. Even though we can use and will be using x. Let's put theta here. Not that we will be using x for angle values eventually, but I'll stick with theta for now. So x is cosine theta, y is sine theta, and let's take the angle pi over 3. So that's 60 degrees. Cosine of pi over 3. Actually, cosine of pi over 3 is 1/2. So I kind of got these in the wrong order. It should be 1/2. Cosine of this should be 1/2, and this should be square root of 3 over 2. A little messy, but okay. 1/2. If I take that and square it, I get 1/4. I take square root of 3 over 2 squared, that I get 3/4, and they add up to 1. So this is basically demonstrating the whole Pythagorean identity. So this should be technically 1/4, and this should be 3. So those in the wrong order. Okay. But anyway, that's just demonstrating the Pythagorean identity. And let's look over here at this other diagram. Again, we have a unit circle here, and I drew a couple of things on here. First of all, I drew an angle. Let me turn the pen off so I don't draw on this accidentally. I drew an angle here, and this is some angle theta that's not in the first quadrant. And so this is the angle, and notice I drew a line also. This t represents a distance around the circle from 1, 0 to this terminal point, and that's the point xy. So this terminal point, this is a p. A terminal point of p is just some point on that unit circle. Again, just like I did when I introduced the unit circle, this xy, this is a general point. This can be anywhere. I could have drawn it here. I could have drawn it here. Just for the purposes of example, I drew it over here. So let's think about what t is. I think your book may make reference to the variable t, and it may say sine of t, cosine of t, and whatnot. And when we're talking about trig functions of real numbers, we're talking about a real number t. Sometimes it'll see it in terms of an angle theta. Sometimes you'll see it in terms of a distance t. But here's the nice thing about radians. Let's think about the distance t. Let's suppose we were going around this entire circle. What is going to be the value of t? Well, it's going to be the circumference. The circumference of a unit circle circumference of a unit circle is what? It's 2 pi. So that's going to be, so for the whole circle, t is going to equal 2 pi. Now, what is, if I take the whole angle, 360 degrees all the way around, what's that equal to? Well, guess what? 2 pi. So you see that t and theta, as long as you're using radians, and this is another reason why we use radians instead of degrees, as long as you're using radians, t and theta are the exact same number. So don't be confused when you see sine of t or cosine of t. That is sine of theta. If, and I want to stress this, if it's a unit circle and angles are in radians. But that's exactly why we use a unit circle with radians. So you can basically, oops, took the pen off, put that back. If it's a unit circle and you're using radians, these two are the same. And the P is just some point. Here's a P, there's a P, there's a P, and there's a P, and there's a whole bunch more P's on there. Okay. So let's talk in terms of reference angles, and I'm going to erase this because I want to keep this same circle. So let me pause for a moment. Well, that's the nice thing about video. See, if you needed this stuff, you can just go back to that last few minutes. Okay. Anyhow, so the question remains, how are we going to figure out these values if these are the only values that we know? Well, we can still figure it out. Now, what we have to use is something called a reference angle. Now, reference angle is as follows. What I'm going to do is I'm going to take this, and let me just draw one thing. Let me draw an arrow on here. What I'm going to do is, and we keep this in red, I'm going to draw an acute angle between my terminal ray and the x-axis, an acute angle. So in other words, my reference angle here is going to be this, and maybe I'll put theta sub r, I don't know. Yeah, theta sub r. This is a reference angle. So this is the reference angle for this. Okay, so reference angle here, that's what this reference angle is going to be. Now, if you're in, here's a good way to figure out, a quick way to figure it out. I'll give you a quick mnemonic here to kind of make this a little easier. Obviously, if you're in the first quadrant, then your reference angle is just going to be theta. There's nothing, obviously, if you're in the first quadrant, it's already an acute angle. If you're in the second quadrant, I want to find, let's see, maybe I have an angle here in my second quadrant. I know I'm kind of making this diagram messy now. I have an angle here. I want to find this acute angle. This is going to be my reference angle. So it's going to be pi, which is this whole angle here, minus this distance. So my reference angle is going to be pi minus theta. That's how you can get a reference angle in the second quadrant. In the third quadrant, which is where we are here, I'm going to take this whole thing, and I'm just going to subtract pi. This whole angle here minus pi is going to give me whatever's left over. This is my reference angle. So theta, not equals, theta minus pi. And in the fourth quadrant, let's say I have a reference angle here. I'm just, okay. At the risk of making this more complicated, we'll do this in green. I have an angle here, and I just want this difference between, so I'm going to make this 2 pi minus theta. This, by the way, assumes that theta is a number. This assumes that theta is between theta is between 0 and 2 pi. If theta is a negative number, obviously you can't just quickly apply this chart. So it assumes theta is somewhere between 0 and 2 pi to begin with. Otherwise, you have to It's a little more difficult. But that's the basic idea. I mean, so you can use this as kind of a reference guide of an easy way to find reference angles. So let's go to another page here. And I want to find the reference angle for, let's see, for 4 pi over 3. I'm not going to do a whole lot of these here, but for 4 pi over 3. Now, what quadrant is 4 pi over 3 in? Well, 4/3 is between 1 and 3/2. I see that here's 1 pi, here's 3/2 pi. 4/3 is greater than 1, and it's less than 3/2. So that's going to be in the third quadrant. So it helps to kind of be able to figure out what quadrant these things are in. So this is in, which this is in quadrant 3. And so how am I going to figure out? Well, the reference angle, so yeah, theta is 4 pi over 3. And so the reference angle is going to be 4 pi over 3 minus pi. I don't know why this is slanted, but that's because my tablet's at a slant. To me, it's upright. Anyway, so 4 pi over 3 minus 3 pi over 3 gives me pi over 3, and that is my reference angle. So what can we do once we have the reference angle? Well, suppose I need to find out the cosine of 4 pi over 3. That's not in the first quadrant. It's not one of our special angles. Well, okay, cosine 4 pi over 3. Well, you already know it's in the third quadrant. And what sign, S-I-G-N, does cosine have in the third quadrant? In the third quadrant, cosine is negative. And we figured out our reference angle already. Negative cosine pi over 3. Now we know the cosine of pi over 3 is 1/2. So the cosine of 4 pi over 3 is negative 1/2. Let's go back to the diagram. 4 pi over 3, and the x value here is negative 1/2. I think we have time for one more quick example. We have less than 2 minutes left. Okay, I'll try to squeeze one more in here. Tangent. Let's start another page here. Tangent of, let's say, 7 pi over 4. Now, 7 pi over 4 is just under 2 pi. So this is going to be in quadrant 4. Now, quadrant 4, so I need to figure out the reference angle. Well, it's going to be 2 pi minus 7 pi over 4. And because we're running low on time, I'm just going to say this is going to be pi over 4. Tangent is negative in the fourth quadrant. So this is going to equal negative tangent pi over 4. Tangent of pi over 4 is 1. So the answer here is going to be negative 1. Tangent 7 pi over 4. Here's 7 pi over 4. And of course, it's sine negative pi over 2 divided by negative square root of 2 over 2 divided by square root of over 2 over square root of 2 over 2, and that's going to be negative 1. And that's why we got negative 1 as an answer.